So friends, let's solve some more questions. Now in this question he is asking the maximum number of electrons possible in 4d orbital R. Now this is a type of a question in which 90% of the students tend to make mistake. Now what kind of a mistake they tend to do is, let's see the solution. And the solution is, we are talking about 4d orbital. Now this is 4d subshell. This complete is 4d subshell, and the number of electrons possible in 4d subshell is equal to 10. And he is asking about 4d orbital. So there is a difference between subshell and orbital. So this is an orbital, and the number of electrons possible in this orbital or any other orbital is equal to 2. Therefore, third will be our correct answer. So answer is option number 3. So it's my advice to you, please read the question carefully, whether he is asking about the subshell or orbital. Let's move to next question. Now in this question he is asking the maximum number of electrons having ms, that is spin quantum number, is equal to plus half, means electron is moving clockwise direction in the 4d subshell R. Now 4 options are given to us. Let's move on to the solution, and the solution is, this is 4d subshell and there are 10 electrons. Now arrow up means electrons are moving in the clockwise direction, and arrow down, the electrons are moving in the anti-clockwise direction. So there are 5 electrons which are moving in the clockwise direction and 5 are moving in the anti-clockwise direction. Therefore, the answer will be second. So answer is second, right? Let's move on to next question. Now in the next question he is asking, find the orbit angular momentum and orbital angular momentum of the electron present in 3d subshell. Now this is one more question in which 90% of the students tend to make mistake, and where they tend to do that mistake, they are asking orbit angular momentum and orbital angular momentum. So read the question carefully, whether orbit angular momentum is asked or orbital angular momentum is asked, because both are different things. Let's solve the question and find the difference. So the solution of this question will be, the orbit angular momentum, orbit angular momentum now this we have studied in Bohr model, and that was mvr is equal to nh upon 2 pi, right? Now n is the principal quantum number and we are talking about 3D. So if we are talking about 3D, so for 3D, n is equal to 3 and L is equal to 2. N is the principal quantum number and L is azimuthal quantum number, but we need principal quantum number here. So let's solve the question. The orbital angular momentum will be that mvr, that is orbit angular momentum, that will be equal to 3 into h upon 2 pi, and we can write it 3 into H cross. We have already discussed what is the meaning of H cross. H cross is H upon 2 pi. Now let's find out the orbital angular momentum. So orbital angular momentum we have discussed in quantum mechanical model, and the formula of orbital angular momentum, the orbital angular momentum and that is equal to H upon 2 pi under root L, that is azimuthal quantum number, L plus 1. So this is the formula of orbital angular momentum. Let's find the value. The value will be, now since we are talking about 3D subshell, the value of L we have already found, and the value of L is equal to 2, and you can put this value here, 2 multiply by 2 plus 1. So if we further solve it, we will get H upon 2 pi multiplied by under root of 6, and again we can write it under root of 6 into H cross. So this is the difference between orbit angular momentum and orbital angular momentum. So guys, I hope that you understood everything very well about the quantum mechanical model. Now in the next lecture we are going to discuss about the graphs of xi and xi square with the radius and the electronic configuration. Till then, goodbye.